Okay, good afternoon and welcome back to the fall semester and welcome to Physics 1320 and also Physics 3320. So this is the fall 2025 version of Music and Physics. I'm Professor Olness, and also this is team taught with myself and Professor George Baker. And let me start by apologizing that I'm not there in person. As part of my work at SMU, I do research on high energy particle physics, and I do theoretical calculations for both the Large Hadron Collider over in Geneva and the upcoming Electron Ion Collider in New York on Long Island. And I'm at a conference this week, so I will be away, but I will be joining you next week. Um, that's a little bit about me. And then this course is team taught with Professor Baker. And this course is unique in the sense that it has generally both professors are in the room at the same time. And that gives it a special mix because, my background, I'm a professional physicist and amateur musician. I play the trumpet, a little bit of piano, and then Professor Baker is a professional musician with a passion for physics. And by having both of us in the classroom at the same time, you get both perspectives together. Now, this course has been going on for about 25 years now and was originally taught with Professor Tom Tunks of the music school. And then when he retired, it took us a while to find someone that we could, continue this tradition. But graciously, Professor Baker has come out of retirement to join us for this, and it's really a special treat to have him. He's a world-renowned, award-winning organist. He won the Chartres competition, I believe, in '74. Professor Baker can clarify and tell you a little bit about that. But he's a world-renowned organist, has performed at Notre Dame and cathedrals across the way. He just had a big composition that was premiered in London earlier this month. And so to have a musician of his quality joining us for this course is really a special treat. So I've known him as a friend for a long time, but it's a real pleasure. This will be the second time we've taught this together, and it's a joy for me. It's just one of my favorite courses to teach. So welcome. Please give a warm welcome, Professor Baker. Um, so let me just go through the syllabus, and you have a handout of this that has the key elements. So I'll go over this in turn. The first thing is there's lots of material put up on Canvas, but you also can find some material on my course webpage, and that's linked from the main webpage. If you Google Olness, I'll show that to you after I go through these handouts, but if you Google Olness, you'll find it fairly easily. So in terms of the class meetings, so the class lecture is Tuesday, Thursday, 2 to 3:20. It'll be usually in this room, but occasionally we'll move to different rooms. So beware. If you come here and find it empty, that's probably because we're doing a special presentation somewhere else on campus. The lab for this course is Monday, and there are 3 times. It's at 1 o'clock, 3 o'clock, and 5 o'clock. And that'll be downstairs in front in Science Room 60. There was no lab yesterday, Monday, the first day, and the next Monday is Labor Day. So our first lab will be on September 8th, Monday. And so come to the lab session you're assigned. Now, a note here, the lab is only for the people taking Physics 1320. That's the introductory course that satisfies the general curriculum, university curriculum requirements. There's a few of you in the physics major version, the 3320. This is an upper level physics course, and we will share the same lecture, but instead of going to the lab, the students in 3320 will get together once a week and we'll dive into the deeper mathematics behind these things. And so we'll do differential equation, Fourier transforms, things like that. So do check and make sure you're in the right section. If you want credit for the university curriculum, you need to be enrolled in 1320 that has the lab component. If you want the upper level physics credit, then you take the 3320 and we'll do the fancy mathematics that goes with it. Okay, so that's the important point. Yeah, and I remind on beware on certain days we may move to a different room and we'll announce those in advance. And the first lab is on Monday, September 8th. And next week before the lab, we'll tell you what to expect. There will be a pre-lab that you do in advance. Because one nice feature about this course, the labs are 2 hours. And then if you prepare and do the pre-lab and hand that in when you arrive, that way you can do the lab in class, you write up your lab in class, and when you walk out, you're done. We don't want you taking your lab books home and writing a novel afterwards. If you prepare properly, it'll take you 2 hours, and then after the 2 hours, you're done, and that's it. So that's the format of the lab. And yes, again here, for the 3000 level, we will have a weekly recitation section in place of the lab, and I will have to schedule that when I know what your schedule looks like. So I will email you separately to find out a time that we can gather for that. The text is John Backus, the Acoustical Foundation of Music. This is an old book, but it's got the basics in it. We used to use a book by Hall that was a more modern book, but the format of that wasn't quite so good. And at one point, the price of that got to be over $300, and it just wasn't worth it. So we'll give you some references, and if you like, we can play some books on reserve, but this has the basics that you need. And then the grade components for the course for the 1300 version, the exams are 50%. The daily quizzes are 20% and the laboratory is 30%. So during the course, there will be 2 in-class exams. Those are 15% each, and the finals were at 20%. The laboratory counts 30% of your grade, and if you prepare the lab, come show up and do it, everyone does well. On the laboratory, the difference between the A's and the lower grades are basically those that do the pre-lab in advance and do a nice job. If you're in the lab and follow the instructions, everybody does well in the lab, but the pre-lab is what usually differentiates the grades there. And then the daily quizzes, in place of an additional exam, we'll just have a short quiz at the beginning of class. And I'll show you an example of that, but that's just usually 3 questions. And not only is it 3 questions, if you get 2 out of 3, we'll give you 100%. We used to offer a music psychology course. There's no one enrolled this time, but that's the breakdown. And then for the people in the 3000 one, it's a little bit different. The exams, daily quizzes, and there we have a little bit more homework instead of the laboratory. So that's the breakdown in the grades. For the class project, sorry, on the quizzes, will allow you to drop a certain number of quizzes. You can drop 2 quizzes automatically, but then if we'll have some special extra assignments that allow you to drop extra quizzes. For example, we'll have an evening organ demonstration, and that will allow you to drop a quiz. And another one is at the end, the last day of class, we'll give you the chance to present a class project. And so you can work in groups of up to 3 on a project that you come up with, and then you present it. And then if you do a good job, we'll let you drop 3 quiz grades for that. And I'll talk about that a little bit later. The music psychology, we'll skip that. And then for the physics 3320, we'll be using computer-based homework. So I recommend you install Mathematica on your laptop. We have a site license for that. I can help you with that. And also we may be doing some Jupyter Python-based calculations. So we'll get to that later. The content will cover the acoustics, the physical sound properties, but also the psychoacoustic properties, how the brain processes the music. And we'll get both sides of those. And so we'll have a mix of those along with some demonstrations. And for me, that's one of the things that originally attracted me to physics, that they had fun toys to play with. So in the back room there, we've got various demonstrations, and we'll be pulling those out for you during the class and also during the lab. Particularly in the later part of the lab, we have some very neat equipment that you can play with. And yeah, so there'll be various problem sheets throughout, and then those are just for you to practice. So, and I'll show you that when I get to the web page. Office hours, we will post them, but also by appointment. So the posted office hours for both myself and Professor Baker are 3:30 Tuesday, Thursday, right after class. So if you'd like to catch us right after class and we can chat. But if that's not convenient, or if you have a job or another class, just contact us. You can make an appointment. And our contact information is at the top of the page there. In addition to us, there's also the Osher Learning Enhancement Center. They have tutors there that can help you with physics, not so much with the music. What's kind of challenging here is this mix of the music with the physics. So if you want help on the physics, the Learning Enhancement Center often has physics tutors for that. For the music side, it's probably best to talk to myself or Professor Baker. And then special this year, we actually have some of our former students coming back, and they'll be helping out as TAs in the lab. So you can also take advantage of their expertise. For the course, you will need a scientific calculator. Nothing fancy. A TI-30 is great. You can get them on the supermarket shelves for $15, but you do need one because we have quizzes, a very brief quiz at the beginning of each class. That's how we take attendance. But you cannot use your cell phones, obviously, because that's not what we want. So you do need a basic scientific calculator. So in fact, we strongly recommend you have one Thursday for the quiz, because Thursday's quiz will make use of that. The course webpage is here, link from my webpage. If you Google Olness, you'll find it, and I'll give you a tour of that later. Again, for the 1300 level, 1320, no calculus, no advanced math. Okay, we use a little bit of algebra and trigonometry, very little, and we'll review the necessary material before it's used. So just simple things like if I give you the speed of sound, how long does it take for it to go across the football field? If I play A440, what's the wavelength of that given the speed of sound? Things like that. Quizzes. So there'll be a short quiz at the beginning of each class, and we do that in place of a third exam. And then the lowest 3 grades will be automatically dropped if you complete the group project. Okay, so that gives you incentive to, and we'll talk about that later. But that way, if you have a doctor's appointment, you have an emergency or something like that, you can drop those. For excused absences for officially sanctioned university events, if you're on a sports team or something else, let us know in advance, and then we'll set up to make it up in advance. Okay, we don't make them up afterwards, because then the general formats are public, but we'll do that in advance for officially things. But afterwards, when we give it to everyone else and the general problems are out there, then we don't do that. Homework. Physics is not a spectator sport, and there's suggested homework for each assigned chapter, problems from the back of the book. I don't collect those and grade those. I'm glad to give you help on those, but those may help you as you prepare for the quiz. And then what should you study for the exams? Basically, on the exams, I think it's fair to say that absolutely everything I use on the exam will be touched on in one of the quizzes or emphasized in class. The homework, take a look at some of the selected problems we pick out in the back of each chapter, but the quizzes are very, very telling. And and that also gives you a chance, if you fumble on a quiz and don't understand it, make sure you go back and look it over and get it down before the exam, because a lot of times you'll get a second chance on the exam. Um, okay, and yeah, I don't grade the homework since basically the quiz grade gives me a monitor of that. And again, by doing the quiz every day, that gives you a measure. If you're doing well in the quizzes, that means you're keeping up. And if you start falling behind, that's a sign that, hey, maybe you should catch up and focus a little bit, especially to catch up before we get back to the exam. The final exam is scheduled. That's on the schedule, and I'll talk about that later. The laboratories, 2 hours each. There are three of those, and you'll need a calculator for that, a notebook, which we will give you, and the laboratory manual. There's no laboratory manual, but that will be online. And so that will be online. And then on the web page in Canvas, there will be a short pre-lab assignment due at the beginning of each lab. So that means you have to take a little bit of time to read over what the lab is going to be about, to read over the pre-lab assignment and answer that. Because when you walk in, we want you to hand that in and get right in the lab. That way you can get done and over within the 2 hours. Okay. And as I say, this counts as part of your lab grade. And experience has told us that basically, in the lab, most people do fine. The thing that distinguishes people is the pre-lab. If you scribble the pre-lab down 5 minutes before lab, you won't get a good score, and that's going to pull your grade down. Final remark, I'm sure we missed something. But we'll get to that. Okay. Here is the schedule for the first part of the course. And we're only giving you the first part because the second part, roughly speaking, the format of the course, we'll spend the first few weeks giving you a brief overview of the key physics concepts that you need, and then we will apply them to the instruments. And you'll see in the book, basically, we'll tour the various instrument families. And then as part of this, we want to bring in guest speakers and guest performers to demonstrate the instruments. And in fact, we'll be looking to see what instruments we have within the class and encourage you to bring those in during the second half. So this first part gets us through the exam, which will be Tuesday, September 30th. That'll cover chapters 1 through 5. And again, go back, and a lot of the material will be things I hit on the quiz. So that will be what you focus on. And so I've given you the chapters to focus on here, 1 through 5, and we'll be roughly following that. After this, I will give you an updated schedule once we know when our guest performers and speakers can come in. And as I say, then we'll tour the instrument family and go through that. In terms of the labs, so here's the lab schedule. Yesterday, Monday, August 25th, there was no lab. We didn't want to, people were still signing up and things like that. We wanted to do that. Next Monday is Labor Day, no lab. So the first lab will be on September 8th. And I will prep you for that next week. But this is the format. And then the first 5 labs, 1, 2, 3, 4, 5, going through simple musical instruments, those are, the format of those is everybody will come into the lab and you'll all be doing the same lab at the same time. You'll work in pairs, so you have a partner. And in fact, you'll see many of these are similar to labs that we use in the mainline physics curriculum. So that takes care of the first 5 labs. The second 5 labs, labs 6 through 10, I call those rotating labs. And for those labs, we have more specialized equipment. And so we don't have enough sets for everybody to do the same lab at the same time. So what will happen there is for the last half of the course, you'll come in and group 1 will be doing lab 6 Fourier transforms. Group 2 will be doing diffraction interference. Group 3 will be doing the resonant flame tube. That's a lot of fun as long as you don't, you're working with methane gas is a lot of fun as long as you don't cause explosions. And there's oscilloscopes and Lissajous standing wave patterns. And then the next week you'll rotate. So then group 1 will do this one and et cetera, et cetera. And after 5 weeks, you'll have rotated through all the labs. Okay. Now, there is no class scheduled on the week of Thanksgiving. So Tuesday, the week of Thanksgiving, there's no school then. On Monday, there is no formally scheduled lab, but that's a makeup lab day. So if you do all your labs on time, then you are done. You can take the week of Thanksgiving off and you're free and clear. And we like that because also the TAs and the undergraduate TAs have that week free. If you miss a lab, then you need to make it up. We allow you to drop a quiz, but you cannot drop a test. You can not drop a lab. There are only 10 labs and you need to do all of those. So if, for example, you miss lab one, the measurement and errors, a couple things what you can do. You can wait till the end and make it up on November 24th. Or, for example, if your lab is at 1 o'clock, what you can do is if you come in the next week and do your regular lab at 1 o'clock, if you have time at 3 o'clock or 5 o'clock, you can make up your lab at that time. And we allow you to make up one lab per week. So please don't come in and try to do a lab at 135. That'll overload the TAs. And then on the makeup day, you can make up only one lab. So if you miss all the labs and try to do 10 labs on the makeup day, that won't work. Well, we only allow you to do one lab extra per week. But that gives you flexibility. So if you've got an audition or a concert or a special rehearsal, and you need to miss the lab, that's fine. Just come and you can do it the next week. You need to let the lab TAs know in advance because they need to set up the equipment, but that's flexible. So if you do that, what that means is hopefully no one, let me get my crayon out and where'd it go? My crayon out. So the right way out. And yeah, so if you do that, hopefully no one will need to come in on the wake of Thanksgiving, and even I can stay home. But that's the format for the labs. Okay. And the in-class labs are on a 20-point scale. The pre-lab is on a 10-point scale. So the pre-labs are half the weight of the lab, but generally on the lab, everybody gets pretty close to 100%. It's the pre-labs that generate the distribution. And if you do the pre-lab 5 minutes before the class, you're going to see it in the grade. So just plan ahead and get that done. Let me switch now. These are some sheets. I won't go in these in too much detail. We'll actually talk about these on Thursday. But this is a sheet put together by Professor Tunks because one of the key things we talk about in the first chapter are units. And the basic units we're going to use are length and time and mass. And we'll use the MKS system, that's meters, kilograms, seconds. And then using these quantities, you can build up everything else. For example, if you take length and multiply length times length, you get area. If you add time and length, you can get speed or velocity, meters per second, miles per hour, and all sorts of other things. So this is a nice reference sheet. And again, this is something we borrowed from Professor Tunks. He designed this for his class. The other thing that's sort of useful for the first 6 chapters, we have let me make it a little bigger. We have term sheets. And again, these are drawn from Professor Tunks' material. So here are the term sheets for chapter 1. And so as you're studying for the quiz or exam, you should be able to go back through these term sheets and make sure you understand these basic quantities. Okay. Now, caution later on, this course was shared with the music psychology. So later on, there'll be some more sophisticated terms that we won't fully get into, but at the beginning, they will be. So I think chapter 1 is straightforward. And then likewise for chapter 2, here are the term sheets. And these are on the websites. I'll show you in a moment. But as you're preparing for a quiz or exam, as you're reading the chapter, you should be able to go through and look at these and try to figure out, try to make sure you understand these basic ideas. Okay, moving on. So this is the content of Thursday's lecture. I'll go over this on Thursday, but we'll do unit conversion, part of my sloppy handwriting. But you see, this is the kind of math we expect you to be able to do. So here are the basic formula. Distance in x is velocity times time. And so I tell you, if I'm driving down the road at 50 miles per hour, and I do that for 4 hours, you can probably do this in your head. That's like driving to Austin. It takes me about 4 hours to drive to Austin. Maybe you drive faster. But the formula here says if I multiply velocity times time, I'll get distance. Let's check that out. I got 50 miles per hour multiplied by 4 hours, and this is miles over hours. I have hours downstairs, hours upstairs, so those cancel, and then I'm left with just units of miles, and 4 times 50 is 200, and sure enough, it works out. Velocity times time is distance. So those are the kind of things. That's the level of math we'll be working at. It's just the minimum amount you need to be able to calculate the basics. So that is the end of the handout. Let me now go to the quizzes, and I'll pull that up. And here is quiz one. So we handed this out at the beginning of the class, and normally we'll give you 5 or 10 minutes at the start of class to answer this. But for quiz one, we like to start out, everybody gets 100%, so let's go through it right now. So be sure to put your name on the top here, so we can give you credit. And then, so first question, true or false? It is not necessary to do a pre-lab before the lab session. Hopefully that's pretty obvious. The pre-lab, that means before. And so by doing the pre-lab, you come in and you're ready to go. You don't have to, read through everything. You can get right into it. And in 2 hours, you're done. You've written it up, you're done, and you leave, and there's nothing more to do. True or false? Class will always be in Founder Science and never in Perkins Chapel or the Meadows Building for special presentations, okay? And again, that is false because sometimes we will go down the Perkins or Meadows or even engineering for special demonstrations. We'll announce those in advance, but if you miss a class, do check the website to make sure we're not going to shift on you, okay? Next one, true or false, the quiz grading scheme is as follows, okay? And there are always 3 questions on the quiz. So if you get 3 questions correct, your score is a 3. But if you miss one, if you get 2 out of 3, we'll still give you 100%. And if you miss 2 out of 3, well, we'll give you a 2. And if you miss all the questions, if you miss all the questions, you still get a 1 for showing up. But if you're absent, then you get a 0. Okay. And that way, if one of the questions is a little hard or tricky, or you miss that part of the chapter, you can always miss one question without penalty. Okay. And so that means, again, this sort of replaces a third test. And so if you get 2/3 of the material, you'll get 100% on the quiz. Next one, true or false? In lab, there's plenty of time to carefully read the lab procedure and work out the pre-lab problems during the start of the lab period. Therefore, you don't have to begin the experiments until the last 5 minutes of the period. Hopefully that's absurd enough so everybody understands that's false. It doesn't take long, but you read over the lab, you do the pre-lab before you get there. When you walk in the door, the TA will collect the pre-lab, and then you hit the ground running, and 2 hours you're out of there and everything's done and get a good grade. And then finally, identify the 3 fundamental physical quantities from which all others are built up. And you got a couple of choices here. I'm sure Earth, Wind, and Fire is a very popular one, but unfortunately that's not the right answer as shown on that unit sheet. The answer is length, time, and mass, okay? So if you would go ahead and fill this out, put your name at the top, and everybody gets 100%, and then just pass this in before you leave. Just turn it back to Brandon. And sorry, I should introduce Brandon Stevenson is one of our grad student TAs who's going to be helping us throughout the semester. So appreciate Brandon's help. And then finally, for quiz 2, for Thursday's class, the quiz will cover the video. And there's a hour-long NOVA video that's online. I'll give you the link in a moment. It's linked from the webpage, and I'll show that to you in a bit. And then here's what I'm going to be looking for. Okay, so as you're looking through the video, pay attention to these key points. So what was the point of the Tchaikovsky demonstration? At one point, they have an orchestra. They have an orchestra on stage, and the modern setup for orchestras is to have the first and second violins generally on the left-hand side, and then you have the cellos on the right. But in Tchaikovsky's time, the older setup would actually have the first and second violins opposite sides of the stage. And so take a look. They do a demonstration where they move the orchestra around a little bit. And what's the point of that demonstration? The next one I want you to look for, what is a trick to reproducing the Stradivarius violins? And so Stradivarius was made long ago. Somehow those are absolutely impressive instruments. And for centuries, people have been trying to reproduce the quality of the Stradivarius violin. And in the video, they talk about actually a scientist who thinks he has discovered the secret of reproducing that. And the key is in the wood and some of the details of the wood, and that seems to make a big difference in getting a very good quality violin. So take a look and pay special attention to that part. And then the third part, when you change the shape of the carillon bells, what happens? And there's a part of the video where they talk about taking the traditional bell shape and then they modify it so it has sort of a bulge in the top, but that changes the acoustical properties. And so, take a look and key in that part. So for Thursday, your homework is to go home, watch the video. It's an old Nova video. I know it's antique, but it has still some very interesting things that are quite relevant. So that's what's coming up on quiz number 1. Okay, and let me. Okay, so that's what's coming on the quiz. Oh, sorry. Let me also. Professor Baker will talk about this, but this is a handout he prepared how to do well in this class, and so I'll let him address that. But these are some quite useful thoughts and ideas, and some links down here. And so this tells you how to do well in the class. And but if you want to know how to do poorly in the class, I can tell you that. Basically, don't do the labs, don't do the quizzes, and don't come. If you come and try and attend, everyone does well. Roughly speaking, the A's and B's in this class are competitive, but the C's, if you demonstrate, that by the end of the course you've got the material, that's sufficient for C. So if you bomb a test or something like that, if you demonstrate by the end that you've recovered and gone back and understood the material, that will earn a C. For the A's and the B's, those are more competitive, but generally, I think generally sort of the class GPA average coming out of this is about a 3.3, 3.4. The lab is 30% component, and basically, if you do the pre-lab, if you do the lab, you get pretty much. It's easy to get 100% on the lab, and that's 30% of your course. So, no promises, but if you do the work and pay attention, you'll do fine. But if you miss, then it'll show. Okay, so let me move on. And so if you just Google Olness, excuse me, if you Google Olness, you'll find my webpage. You're free to peruse interesting set of units. You can ponder that one if you like. Now, let me show off a little bit. One of our research papers was labeled by Physics World as the top 10 breakthroughs of the year in physics. And that was sort of fun. It actually combined elements of particle physics, high energy particle physics with nuclear physics, and kind of cross-disciplinary ideas. I think in part that's why it was done. But if you scroll all the way to the bottom, you'll see various course pages, and at the top, you'll see our course. And if you follow that link, that will take you to our course page, Musical Acoustics, Fall 2025. Okay. And there's lots of information here for you. This first link is a Google form. Whoops, hit that. If you would please fill that out, and if you have your laptop, you can even do that now. But if you could just give us some basic information, what's your name? Uh, I ask you for an alias so that I can post grade securely. Uh, if you give me an alias, I can use that. Otherwise, I'll assign you a random number. But that's used for posting grades. So it's best to keep it secret, not identifiable to you. So, for example, if my alias is physics professor, that would not be very secret because you could probably, you got a 50-50 chance who that is. So your year and your major, first, second, third year, what your major is, and a few other things. Tell us a little bit about yourself. We're curious to know, where you came from and where you think you might want to do, what you're interested about learning this course, what are some of your extracurriculars, hobbies, and quite important, what's your musical background? And if you play an instrument or sing or something like that, please put that down because we'd like to use that during the course. When we start touring the instrument families, we'll have you bring your instrument in and demonstrate it. So please go ahead and fill that out. The video for the first week of class is located here. And there are actually a whole bunch of presentations here that things you might find interesting. But right here, if you click this, and this will go to full screen. Let me jump ahead a bit. And again, this I think was done in the 80s. So, some of the material is dated, but nevertheless, it contains some good information. And so this is on the web page. This is in Canvas. If you have any trouble viewing it, email us. But it's 58 minutes, and this will be the topic of the quiz on Thursday. So please take a look at that because we're going to, after the quiz, we'll discuss some of the general things about it. All right, moving on. Let's see, the class Google Doc is here. And this has a variety of information. We'll use this later for the rotating labs, makeup labs, projects. These are interesting links I came across. But the first tab right here, this is if you would like to put in your information, put your name, a phone, email, and instrument, whatever you would like other students in the class, excuse me, whatever you would like other students in the class to know about you. So if you want to work in groups or get together on a project, put your name, your contact information so people can find you. So that's optional, but anyone can look at this and view it. And so that way you know who's in the class. Okay, let me go back. The class Zoom room is here. And so if you click on that, in fact, that's what I'm using now. If you click on that, that will open up a Zoom room. It's not automatically recorded, but if you want to group study with people over Zoom, feel free to use that link. That is for our class alone. There's a grade sheet where periodically I'll post grades or information. I'll also use Canvas, but Canvas can't do standard deviations and histograms and things like that. So sometimes I'll use that instead. Okay, let me clean this up a little bit. All right. And working our way on down. So here's our contact information. Here's the course and lab schedule. That's a copy of what you have in your handout. Here is the link to the labs and the pre-labs. Okay, so here is pre-lab 1. I'll go over that next week, but here it is. You have to read a little bit, and then there are just 3 questions you have to answer. So it won't take long, but if you start that 5 minutes before class, I'm assure you're going to get a poor grade on that. And then likewise, all the lab materials right here, those are online. There's no, oops, there it is. there's no lab manual to purchase. Okay. Um, and then also the syllabus, there's a copy of the syllabus. Um, this is a link to general resources. And so these are just collections of things over the years. I'll point you to this throughout the semester. Professor Baker provided some special material here. This is a presentation by one of his colleagues that he did, various handouts, video when we get to the ear. This is Professor Tunk's presentation, other things, some references, et cetera, and all sorts of links, some cool videos and things like that. So, that's over the years, we've just collected those things. Exam review material, you may find that of use. So that is here. So here is, let's see, they're out of order. That's exam 2 study sheet. Here's exam 1 study sheet. Here's quiz 1. And yeah, so there's lots of review material for you to look at. And in fact, yeah. Um, and then on the exam, uh, we're not so much interested in you memorizing formulas as knowing how to use them. And so there's a set of equations that we'll provide for you. This is an equation sheet that has basic things like, relationship here. The velocity of a wave is frequency times wavelength, and the speed of sound is this, and the beat frequency is that, and all sorts of other things. So we will give you the formulas sheets, and then later on, there's some other ones that we'll use later. So there are lots of answers on these sheets. You just have to know how to read them. And then rotating lab assignments, that'll be in the latter half of the course. We also have a sheet. These are suggestions for projects. And so, these are just rough ideas, but please, if you have an idea, get together, find some partners, work in groups of 2 or 3. And then, if you have an idea, float it by us before you do it. But again, if you do that, then you get to drop 3 quiz grades. As you note here, we have some special dates. So at some point, hopefully, we will again go down to Meadows building, and Professor Thomas Keck will set us up with a special lecture on percussion. And then one evening, I think it's going to be November 11th, we're still waiting to confirm that, Professor Baker will give you a demonstration of the organ in Perkins Chapel, and we'll do both the organ, but also room acoustics at the same time. And that's an evening outside the class period, so that counts for 2 quizzes. So if you come for that, you get to drop 2 quiz grades. And then if for some reason you shouldn't have a conflict, in place of that, you can do this assignment. But I assure you, this hour and a half is fun, interesting, and much shorter than doing this written up assignment. The final exam is Wednesday, December 17th. Be sure to plan for it. Don't book your flights ahead of that. We will have a review Monday, and that'll be on Zoom, probably in the evening. I'll set that up in advance. Okay. And then this is just more details. Here's the suggested homework I mentioned. And I don't collect that, but these are just, not all the problems in the book are relevant to what we're doing. We're focusing on particular things, but and then here I just copied out. If some books don't have the, some of the older editions don't have the questions and problems, I just copy those so you have it. But if you want a little bit extra to make sure you really understand it, you can take a look at those. I won't collect them. I won't grade them. Again, probably the key thing I would recommend is to focus on the quiz problems. So that I think does it. At that point, let me go back to the main page, and I think those are all the highlights. So I will leave it there, and I will turn it over to Professor Baker. He has some intro material for you. And again, it's good to have you in class. Please, again, make sure you're in the right section. You can change through this week, but after Friday, it's frozen. And it's good to have you here. I think we'll have a fun class. We'll have a lot of special guest lectures and demonstrations set up for you. and it should be a lot of fun. As I said, music is my passion, and it allows me to mix, physics with music, and so it's one of the favorite courses I teach, especially having someone like Professor Baker working with me makes it a real special treat. So good to have you, and I look forward to seeing you in person next week. Thank you much. I will finish there.